Okay, so for problem number 1, this was the original equation that was given. Now, when you factor it, you would get x minus 3 times x minus 1 over x plus 1. And you see that no factors cancel. The only time you're going to have holes, right, points of discontinuity, is if factors cancel out. So off on the side, I made up a hypothetical equation where we would have a hole because all the other problems on the sheet don't have any points of discontinuity. So if the problem, just if, your problem looked like this and the denominator said x minus 1, we know that we can't have an x value of 1. So we ask ourselves, is it a vertical line or is it a whole point of discontinuity? Well, because that factor x minus 1 cancels, we know that it's going to be a whole. We know that the x value, the x coordinate of that point of discontinuity is going to be 1. Now we have to find what the y coordinate is. So how you do that is you take that x value 1 and you plug it into this simplified equation. So the simplified equation will be y equals x minus 3 because the x minus 1's canceled. So if we plug 1 into this slot, we would get y equals 1 minus 3 or negative 2. So that's why our ordered pair would be 1 comma negative 2. That's where we would have an open circle at 1, negative 2 if we were to graph. If, hypothetically, that were our equation. But that's not the equation we were working with. So, because this is the equation we see, we set our denominator equal to 0, we get 1. Because the factor x plus 1 doesn't cancel out, we know that we are going to have an entire vertical line, an asymptote at x equals negative 1, which is what we see right here. Then, for horizontal, we ask ourselves, is there one? And there's none because the degree on top is larger than the bottom. Remember, there's 3 options. If the degree on top is larger, there's none. If the degree on top is smaller, it's 0. If the degrees are the same, it's leading coefficient over leading coefficient. So there's none, so we don't see that horizontal dotted line. Our slant asymptote, if the degree on top is 1 larger than the bottom, we'll have a slant. So the degree on top is 2, degree on bottom is 1, so we do long division. So it's x squared minus 4x plus 3 divided by x plus 1. You take the front term divided by the front term. So x squared divided by x gets you x. You put that on top of the x column. You then multiply the x by everything in front. So x times x is x squared. X times 1 is 1x. You then subtract. The x squareds cancel. Negative 4x minus x is negative 5x. Remember, guys, it's a negative 4x on top minus the bottom is negative 5x. And then 3 minus nothing is 3. Again, front term divided by front term. So we do the negative 5x divided by x is negative 5. Once we've filled our constant spot, you're not going to have a remainder for slant asymptote. It's an equation of a line. So we have y equals x minus 5. And when you go to graph that, y equals x minus 5, right? It's a dotted fake line. It's a asymptote, something your graph approaches but doesn't touch. So we have a point, open circle at 0, negative 5, right? If you plug 0 in for x, subtract 5, you get negative 5. If you plug in 2 for x, you get out negative 3. So here are some points that we can put to get that dotted slant asymptote. To find x-intercepts, we put 0 in for y, we solve for x. You first multiply by the denominator, that cancels because you're multiplying by 0. But then we have 0 equals x squared minus 4x plus 3. To solve any quadratic, get everything on one side, factor. We got our factors were x minus 1, x minus 3. Set your factors to 0, you get 1 and 3. So we have x-intercepts at 1 and 3. Y-intercept, we put 0 in for x. We have 3 over 1 or 3. So there's a dot at y is 3. And then I put in my calculator. Remember to do parentheses for what you see on top divided by parentheses for what you see on bottom. I always start with zoom standard. You know that there should be multiple pieces on your graphing calculator. So if you only see one snippet of the graph, you need to zoom out, enter, and then you'll see this piece down here.